For most of human history, intelligence has been individual. One mind, one thinker, one decision-maker at a time. But nature has always shown us another way. Ant colonies, bird flocks, and human societies all demonstrate something profound. When multiple agents work together, something greater emerges. Today, artificial intelligence is entering that same frontier. A world where not one, but many intelligent systems collaborate, coordinate, and compete, forming what researchers call multi-agent systems. These are the foundations of the next great leap in AI, where digital minds don't act alone, but as societies. What are multi-agent systems? A multi-agent system, often called MAS, is a network of independent AI entities, called agents, that interact with each other and with their environment to achieve goals. Each agent can perceive, reason, and act, but the real power comes from their collective behavior. Unlike traditional AI systems, which are centralized and controlled by a single model, multi-agent systems are decentralized. Every agent contributes unique insights, skills, or data. Some specialize in language understanding, others in planning, prediction, or control. When they communicate, negotiate, and collaborate, intelligence becomes distributed. In essence, a multi-agent system is like an organization of digital workers, each one autonomous, yet interconnected through shared objectives. This approach is inspired by biology. Just as an ant colony finds food and builds complex structures without any single ant being in charge, multi-agent AI can solve large-scale problems without direct human micromanagement. The origins of multi-agent thinking. The idea of multi-agent systems didn't appear overnight. It began decades ago in the fields of robotics, game theory, and distributed computing. In the 1980s, researchers imagined swarms of robots working together to perform tasks too big for a single machine. Around the same time, economists and mathematicians developed models of game theory, showing how rational agents could cooperate or compete to maximize rewards. As machine learning evolved, these concepts merged. Scientists realized that the same principles that guide markets, ecosystems, or social groups could be used to design artificial societies of AI. When large language models like GPT emerged, this vision suddenly became practical. Instead of physical robots, we could now create digital agents that communicate in natural language, delegate tasks, and reason about one another's actions. Today, systems like OpenDevin, AutoGen, MetaGPT, and ChatDev showcase the next stage of evolution, digital ecosystems of AI agents collaborating like teams of humans. How multi-agent systems work. At their core, multi-agent systems operate under a few fundamental principles: autonomy, communication, cooperation, and coordination. Autonomy. Each agent can operate independently. It has its own goals, reasoning process, and ability to act without external control. Communication. Agents exchange messages, often in natural language, to share knowledge, ask for help, or negotiate solutions. Cooperation. When goals align, agents form coalitions or teams, dividing work based on skill or specialization. Coordination. The system manages timing, dependencies, and priorities so that multiple agents don't conflict or duplicate effort. In many setups, a manager or orchestrator agent supervises overall strategy, while other agents handle specialized subtasks, like coding, data analysis, content creation, or web research. This is remarkably similar to how human organizations function. Executives set goals, managers delegate, and teams execute. The difference is that these digital agents can operate 24/7, scale instantly, and analyze data faster than any human workforce ever could. Applications across industries. Multi-agent systems are no longer theoretical, they are transforming industries around the world. In finance, networks of AI trading agents analyze global markets, share risk assessments, and balance portfolios collaboratively. Some agents specialize in predicting volatility, others in detecting sentiment from social media or news. In logistics, fleets of autonomous drones and vehicles coordinate delivery routes, avoiding collisions and optimizing fuel use. Amazon, FedEx, and Tesla are experimenting with AI swarms that learn from one another in real time. In healthcare, multi-agent systems assist in diagnostics, treatment planning, and resource allocation. For instance, one agent can identify medical patterns in imaging data, while another cross-references treatment outcomes or genetic factors. In education, multi-agent tutors can work together, one assessing a student's learning style, another curating resources, and another providing personalized explanations or practice questions. And in cybersecurity, agents defend digital systems by monitoring for threats, analyzing vulnerabilities, and coordinating responses, like an immune system for the internet. This decentralized approach enables adaptability, scalability, and resilience. qualities that centralized AI systems struggle to match. Emergent intelligence. One of the most fascinating aspects of multi-agent systems is emergent behavior. Intelligence that arises from the interactions between agents, rather than from any single one. When many agents collaborate, unexpected abilities emerge: negotiation, compromise, innovation, and even creativity. Researchers have run experiments where AI agents simulate small societies, forming friendships, holding debates, and developing hierarchies of leadership and trust. In one famous experiment from Stanford University, 25 AI agents were placed in a simulated town. They woke up, planned their days, interacted with each other, and even organized a Valentine's Day party, entirely on their own. None of this was explicitly programmed. It emerged naturally from communication and memory. This experiment revealed that when language models interact with each other at scale, social intelligence can form spontaneously. In the future, this could lead to AI research teams, design collectives, or digital organizations that run independently, proposing ideas, testing hypotheses, and building technology faster than any human-led group. Multi-agent systems in science and engineering. Multi-agent collaboration is also transforming scientific research and engineering. In climate modeling, agents divide massive datasets into smaller parts, simulate atmospheric behaviors, and share insights to improve accuracy. In space exploration, NASA has explored multi-agent control for satellite constellations and planetary rovers, allowing them to distribute tasks like terrain mapping or resource scanning. In smart grids, energy management agents balance supply and demand dynamically, reducing waste and preventing blackouts. And in manufacturing, AI-driven robotic swarms build, inspect, and maintain systems together, communicating continuously to ensure precision and efficiency. Each of these examples shows a shift away from centralized intelligence toward collective intelligence, the same force that drives evolution and civilization itself. The economics of digital societies. As multi-agent systems grow, they're beginning to shape the economy in unexpected ways. Digital agents can represent companies, clients, or consumers, negotiating prices, services, and contracts automatically. This has led to the idea of AI economies, where autonomous agents trade resources, compute power, or data value using digital currencies or blockchain. For example, one agent might provide weather data to another that manages agricultural planning. In return, it could receive tokens or access to other AI services. These decentralized markets of intelligent agents are early blueprints for machine-to-machine economies, a world where value creation happens continuously without direct human input. In such a world, economic systems could become faster, more efficient, and far more complex, powered by billions of micro-interactions between digital entities. Challenges and risks. But the rise of multi-agent systems also brings serious challenges. When autonomous entities interact, unpredictability increases. Coordination failures, conflicting objectives, or communication errors can lead to chaos, much like in human organizations. Conclusion: the next evolution of intelligence. Human intelligence has always grown through collaboration. Language, trade, and society turned isolated minds into civilizations. Multi-agent systems are the next chapter of that story. Digital civilizations born in silicon, guided by code, and shaped by data. They represent not a single intelligence, but the merging of many, human and artificial, working together. The future may not belong to one superintelligent AI, but to billions of interconnected agents forming vast, adaptive networks, intelligent swarms that learn, evolve, and create together. And as we build them, we must remember, collaboration is powerful because it multiplies potential. The question is whether we will design these systems to reflect our best collective instincts, cooperation, empathy, and wisdom, or our worst, competition, greed, and control. Because in the age of multi-agent intelligence, the true measure of progress will not be how smart our machines become, but how well they learn to work, together and with us.